Hello, Python coders. We're going to take a look at chapter 7 here today. I think we might have taken a look at it already, but just in case we didn't, let's take a look at chapter 7 about lists and tuples. Now, actually, we don't cover tuples. We only are responsible up to 7.8. So everything up to 7.8, but nothing after that is on our course. We just don't have time for it, unfortunately. Well, let's just talk about what a list is. A list is a data structure in Python and in other programming languages as well, by the way. But what that means is we're going to be looking at a data structure that has more than one value. So far, when we've been working with data, we had variables which stored a value, one value. It could have been a float, it could have been an int, it could have been a string. Those are the main data types that we've been using. Well, what we're going to look at here in chapter 7, we're going to look at lists, which is an aggregate data type. In other words, it's a collection. You can have more than one value in a list. In fact, you could have hundreds or thousands of values in a list if you needed to. So what it is, it's a data structure that contains more than one value. You can think of it as you can look at it in two ways. You can look at it as a collection of values with one name, which is a good way to look at it. But you can also look at a list as a variable with multiple slots for holding values. Either one of those views can be useful when we're working with lists. And lists open up an amazing amount of capabilities for us when we're coding in Python. We can do so much with lists. It's very, very cool. And we hope to demonstrate that to you today. So let's start working through this chapter here. It's also known as a sequence. Notice here it does say multiple items of data, one after the other. And you can make them pretty easily with a set of square brackets. So I'm going to fire up a Python interactive window here. Let's get a new one up here. And what we'll do is we'll try creating a few lists here. Now, as we all know, at this point, when we're working in this window, we are only we're not programming. We're just testing lines of code, right? Well, to make a list, what you do is you use square brackets. Now, I don't even have to name it when I'm in this interactive mode. Like I could just go 1, 2, 3, 4, 5 inside square brackets with comma separators. That's a list of the integers from 1 to 5. But normally you'd want to give that a name so that you could do something with it. So I'll call it nums, and I'll try some different values. We can put any values at all in here, even numbers with decimal places. They don't all have to be integers. Python even lets you put strings in here. Which normally you don't, normally it won't want to do this, I don't think, in an application that you're developing. But Python is a scripting language, and so it's a little bit more flexible. It's a little loose when it comes to what you can put in a data structure. And here I have a list called nums, which isn't all nums. Obviously, I've got 2 strings in here, and I have mostly ints, but this one here is a float. If I type nums, you'll see that that's all been stored. And here's a really key point. Each one of these elements, that's what you call them, by the way. When you have a list, each of the values in a list is called an element in the list. And to access a particular element, you do so by its index. And indexing starts at 0. So if I tried nums square bracket and put a 0 in the square bracket, that should give me the first element in the list, which it did, the 10. if I tried nums, so indexing starts at 0. If I tried nums with a 4, does anybody know what that's going to print when I press enter here? Now, what you have to be careful of, it's not the 4th one. The indexing starts at 0. So this is 0, 1, 2, 3. It should be this 5.35 should be what I get from this one. Yep, there it is. Okay, so the elements of a list are indexed starting from 0. Now I think I'll go back to actually using some numbers. I'll go with, because it's very unusual to mix strings and numbers in the same list. It's not very likely that you want to do that in an application. So what we'll do is we'll try 10, 20, 30, 40, and 50. Commas in between them all, that's a requirement. Now, we can do other very interesting things with lists. There is, for example, a len function. You know that it's a built-in function in Python when it shows up in purple. So if we type in len nums, it'll tell us how many elements are in that list. And of course, it's 5. But the index of this last one is not a 5. The index of the 50 is 4. Remember, it starts at 0, so it's 0, 1, 2, 3, 4. So if you have a 5-element list, the index of the final element is 4. Keep that in mind. That's something that you always want to be aware of. Now, what's really kind of interesting about a list is it works beautifully with a loop, particularly a for loop. A for loop and a list work beautifully together. Here's the best way to get the nums list. And by the way, this is a little bit unacceptable in a program. This is just, I call this dumping the list onto the screen, because that's all this is doing. It's dumping the list, including the square brackets, including the commas. Well, normally we wouldn't want to do that in a program, but it's a good way to see what's in your list, because sometimes what's in the list is not what you think is in the list. So if you just print the name of the list, you'll see what's in there. But I want to show you how beautifully you can go through a list with a for loop. So we'll go with for, and I'll use n in nums. That's all you have to do, for n in nums. And then what I'm going to do is I'll print n, follow that with the AND operator to separate everything by a single space, which, as you know, that should do there. Now I have to press enter twice to finish that. And there it is. Now this is superior to just dumping it out on the screen like this. Now I've printed the values, but I don't have the square brackets and I don't have the commas, right? But look how you can go through a list element by element. Every time this loop cycles, n picks up the current value in the list as you go through, as you're going through it. So the first time through the list, n is going to be the 10. Next time through the list, n is the 20. Next time through the, next time through the loop. Next time through the loop. Each time the loop executes, n advances to the next element. I hope that's fairly clear. Now, you'll see this kind of stuff is in our textbook here. If I advance a page or so, you can see they've created a list of even numbers here. And here they've got a list of names, which you can do, right? You can put strings inside of a list, that's okay. Very often you might want to do that. And you can mix them up, as you can see here, although it's not normally done as a rule. If you just print the name of a list, it dumps it out onto the screen. In this interactive mode, we don't need to use the word print, right? But we can. we certainly can, but we don't have to. If we just type nums in this interactive mode, we get the same result as printing. But in a program, that wouldn't work, of course. You'd have to use the print function inside of a program. Now, there's also a built-in list function that we can use to convert certain types of objects to list. And here's a really good example here, right at the bottom of this page. Numbers equals list range 5. Let's try something like that. I'll call it numbers. Numbers equals, now I'm going to use the list function and the range function. So I'll go with range, but instead of 5, I'll go with 10. Now, I'm opening 2 parentheses, so I have to close 2 parentheses here. Okay, so this is another quick way to make a list. Let's see what's in the numbers list now. From 0 to 9. You know, that's what range 10 means, doesn't it? Range 10 means you're going to go from 0 to 9. Remember that range function, you never get to the 10. You get to 1 less than whatever this number is. So that's pretty cool. You can very quickly make a large list by using list and range. Let's just demonstrate how quickly you can make a list. I'll put in, I'll try a bigger number. How about 2? Maybe that's a bit too big. How about 200? Boom, just like that. We got all the numbers from 1 to 199. Remember, we don't get the 200. We got all the numbers from 0 to 199 in this list called numbers. And now I could work with this. People who are doing stats, they love lists, the list structure, because they can quickly generate some numbers and then do some stats with those numbers. Everybody okay so far? Any questions?
No.
Yeah, okay. Okay. Kind of cool, isn't it, what you can do with a list? It's a great way to deal with a group of numbers with one variable, just one variable name. Let's see what's coming up next here in this chapter. As you know, the range function can take more than one value inside the parentheses. So I think we should take a look at that too. Let's try that. I'll go with a new window, pretty much use that one up. So let's go with nums equals list range inside that. And why don't we go with 10, 21. Now, I want this to go from 10 to 20, so I'm going to leave the 21 there. So let's see what that gives us. As you know, when you put a first number inside the parentheses of range, that's your start value. So this goes from 10 to 20 by 1. By default, it goes up by 1 each time. But we could put a third number in there for a step value. So I could put here 2. That means give me every other number between 10 and 20 inclusive. So a step of 2. So let's see what that gives us. Yeah, we get the even numbers, every other number from 10 to 20. So the range function is very useful. You can use it to generate a list of numbers quite quickly. Okay, I'm just going to keep rolling along now. Please jump in and ask a question if I'm going too fast or if there's anything that's unclear. Now this repetition operator is quite interesting. If you want to quickly make a list with certain values in the list, you can do that with the repetition operator. It looks like a multiplication sign, but it isn't really. I'm just going to go with n for this. I'm going to call this list n. And what I'll do is I'll do a 0. times 10. Now that looks like multiplication. I shouldn't even say times 10, because in this case, I'm using the asterisk here as the repetition operator. So if I look at the value of n after that line, I've got 10 zeros. Their indexes would be from 0 to 9, but I get 10 zeros. Now, you can also do something like this. So I'll give this one a different name. You could have like 1, 2, 3 times whatever, any number you want. I'll do this one times 6. Let's see what N2 is. I should get 6 1, 2, 3s. And there they are. 1, 2, 3, 1, 2, 3. So that's interesting. This is called the repetition operator when you do that. So that's another interesting and quick way that you can make a list. And quite often you'll want to do this, by the way, assign 0 to all the elements in the list. If you're running a program that's going to count things, for example, this is a good technique. Setting all the elements of a list to be a value of 0. And then you're basically going to use that list as to count something in a program. That can be very useful. And here's how easy it is to go over a list with a for loop. All you have to do is some code like this. Very, very easy. Now you could use a while loop too. Let's have a look at that. Sometimes you'll want to use a while loop. There are certain situations where you might want to use a while loop. So let's try. We'll go back to nums again. Nums equals. We'll go with list range. And what I'll do is I'll go from 10 to 100 by 5, but I want to include the 100, so I have to make it more than 100, so I'll make it 101, and I want to go with a step of 5. So that's going to give me the numbers from 10 up to 100, increasing by 5 each time, step of 5. Okay, so that's pretty cool. Now, a while loop. Let me just make this window a little bit larger here. Just erase part of that line. Yeah. I'm going to start a new window. We'll just kill this one and we'll start another new window. And I want to show you how you could iterate over a list with a while loop. So what we'll do is we'll make that same list again. No, I don't want to use capitals because that would mean a constant, wouldn't it? So we don't want to use constant here. So we'll go with list range, and we'll start at 5 this time. 5 to 100 by 5s. Okay. So now what I want to do is I want to go through this with a while loop. So I could do that by creating a variable for the index. And I'll start it at 0 because remember, the first element in a list is index 0. Let's just display this list here before we carry on. So there's the list from 5 up to 100, as you can see. Now, if I let dex equal 0, that's the index of this first one here. So what I could do is I could go with a while loop here, and I could say while dex is less than the length of my list, which is nums. len nums would be the size of the list, how many numbers we have in the list. So what I'd like to do is I'd like to print out each element. So what I'll do is I'll print, and I'll use an F string. So I'll print in my F string for my placeholder. I'll put the name of the list, nums, and then square brackets. And inside the square brackets, I'll put that dex variable. Okay. And now I would like this to continue, print them on the same line, separated by a space. So I'll add the end operator and put a space here. Now, if I finish this right now, can you tell what's going to happen? Should this print them all out? What do you think? Will this print out all of them? Well, it's kind of a bit unfair of me, perhaps, to ask you that question at this point in your list career. So the answer is no. I'll press enter a couple times. Watch what we get. We have what's called an endless loop. Always a danger. It's repetitively printing index 0. Okay, if you're a big fan of the number 5, you could stop that and make some wallpaper with that if you wanted to. Okay, but we won't. So what's wrong there? What went wrong?
Wouldn't you have to have something that ends the while loop? Like, doesn't all while loops have to have something to end it?
Yeah, that's right. And in this case, what would end it? I have to increment that dex variable, right?
Okay.
So I'm going to go back and make that all over again here. We'll go with the while loop here. So it's going to be while dex is less than the length of my list, which is called nums. And I want to print out, we'll use an F string. I want to print out nums square bracket dex inside my placeholder. And then I want to separate them all with a space. So that's where the end equals an empty string comes in. Now, the problem is dex is at 0 and dex is staying at 0. I don't have any code here that's changing the value of x. So what I need dex plus equals 1. I need to add 1 on to the value of the dex variable in every loop iteration so that it'll walk through the list element by element. So this should print them all out. And there they are. So that's one way you could do it. But by far, the easiest way to go through a list is with the for loop. So I'll just repeat that again. With the for loop, we just have to say for n in nums print f, use our placeholder, put the n in there. We don't have to bother with the square brackets at all. Much easier. And we have no danger of an endless loop. So much easier with the for loop, I think you'll agree. Only takes 2 lines, and those 2 lines are not as complex as what we have up here. But sometimes you'll want to do it. Sometimes you will want to use a while loop to go through a list. So it doesn't mean you can forget about it completely and always use a for loop. Okay, let's see what else we've got here to take a look at in our textbook. Yeah, this is just showing you how how the num variable advances through the list. First time it gets the first element. As the loop cycles, in the second iteration, it gets the 2. Next iteration, it gets the 3. And the last iteration, it gets the 4. So pretty straightforward there. I hope you're okay with that. And we did talk about indexing. Starts at 0. The len function will tell you how many elements are in the list. That's particularly useful in a while loop. Oh, look, here's a while loop right here. This is very similar to what we did. They've used the variable index, and I just shortened it up to be dex, but you could call it whatever you want. And certainly a for loop is a little easier. You could even do use a for loop and the range function if you wanted. It's a little bit more complex because you have to then use the len here, and you have to use the index. So there's another way that you can go through a list with the for loop. Why don't we try that one here? So once again, we would say for, yeah, we'll call it index. We could call it anything we want. And then range. And then we have to use the length of our list. Our list is called nums. 2 closing parentheses, one for len, one for range, and one for len. And then what we want to do is print. And I'll use an F string because as a rule, that's what we always want to do. Let's go with F string here. So what I want here is nums and square bracket with my index variable inside the square brackets. Now, if I just leave it like this, it's not going to print all in one line, which is okay. So let's see. Oh, I didn't finish my parentheses here. Better finish the parentheses. There it goes. From 5 to 100. But because I didn't use the AND operator, each one prints on its own line. I mean, I would only do this if I had to, personally, because this is so much easier. Don't have to worry about the index variable. The one good thing about it compared to the while loop is you don't have to use this dex plus 1 thing because the range function handles that for you. So I hope you're okay with that. Any question about that one? No,
No.
We're good? We're good, okay. You guys are either very sharp or else you're watching the NFL football game or something. Just kidding, I know you're into Python. Okay, a list is mutable, which means you can change the values in the list. If you want to overwrite any one of the elements, you can do so just by specifying its index and modifying it. So for example, I could do that very nicely with a loop. Let's just try that. We'll fire up another window here and we'll try nums equals. And this time I'll just do the numbers from 1 to 6 by typing them in. But now I could go through that loop. I could say for n in nums I'm sorry, I better use the range function for this. Better use the range function here. For n in range, len nums, what we should be able to do is say nums And maybe I want to square each one. So let's see if that works okay. I'll say nums n equals n squared. See if that works out okay. Let's see what's in nums now. There they have. We've got the squares. Now it started with the 0 and it stopped at the 5. It didn't go all the way up to squaring the 6. So what if I wanted to do that? I'd have to say here 1 comma nums plus 1 if I wanted to get every one of them. So like I guess I could repeat this and just modify it here to say nums n trying to modify that, which I should be able to do. Nums n plus 1 equals n plus 1 squared, I guess it would be. Getting a little more complex than I had envisioned here. So I'm going to have to put this inside parentheses. See if this does what I was thinking of. I'm not sure if it does. Yeah, I made a mistake there somewhere. But I think you get the idea that you can change the values in a list. We could add on to them. We could square them. We could multiply them by something. We could certainly do that. All right, that was moderately embarrassing, but we're flying by the seat of our pants with these examples here.
Can I ask, is the reason that it didn't capture that 6 and it didn't square the 6 because it was a range, so like you would have had to do another number after that and it would have captured the 6?
Nums plus 1, right? If we had nums plus 1.
Mm-hmm.
Yeah, I think you're right. Yeah, I think that would have worked okay. Okay. Let's see what's next in our book here. And by the way, I haven't been using the Dunder's expression, which we should be using all the time now. So my bad. Well, actually, I haven't written any programs. I've just been messing around in the interactive window. So we better start writing a few programs here. And the next thing that comes up is concatenating lists. Well, that's the big fancy computer term for adding lists together. Hitching them together, making a bigger list from 2 lists is called concatenation in computer programming lingo. And it's, you just add them together, you get a bigger list. Notice it just takes a plus sign to do it. So the plus sign doesn't mean just addition. It means you can also add some lists together. Now, slicing. This is a little tricky. This might require looking at a couple of times. List slicing. What this is all about is extracting part of a list to make a sublist. That's what you do when you create a slice. So you can sort of think of it like you might for a like for a loaf of bread, which consists of multiple slices if it's been sliced. Well, what you can do with slice syntax is you can extract a certain number of slices out of that loaf of bread. And to do that, you use the indexes and a colon inside square brackets. So just as an example here, I'm going to fire up another interactive window and we can take a look at it. If we tried nums equals list, I'll use list in range this time. And I'll go with 1 comma 11. So that should go from 1 to 10, right? Okay, so now what I want to do is I want to try nums square bracket 2:6. This is slice syntax. Whenever you see the square brackets, that means you're accessing part of the list. Well, if you see a colon in there, that means this is a slice that we're creating. So what we're trying to do here is we're going to extract elements from 2 to 6. Now that doesn't mean the 2, that means index 2. Well, index 2, indexing starts at 0. So this is 0, 1, 2, 3, 4, 5, 6. So you might think we would get 3, 4, 5, 6, and 7 from this, but we don't. I think you're going to see we only get 3, 4, 5, 6. So the way this works is you don't get to this last one, kind of like the way the range function works, right? Just like we didn't get an 11 up here. When you create a slice, you don't actually get to index 6. You get to index 5, actually. From index 2, 3, 4, 5. Stops right there. If I wanted to get to 7, I'd have to say 2:7. So if you have two numbers inside square brackets separated by a colon, the first one is the start index, and this second one is the ending index, but less by 1, decreased by 1. But there are variations of this too. You can do, for example, you could do, here's an interesting one. If you leave this first number out, and I'll change this from 6 to say 8. If you leave the first number out before the colon, that means that's equivalent to putting a 0 in there. So you'll see it starts at the very first element. So in other words, it's the same as doing this. You got the exact same output, right? So if one is missing. You can also do something like this. Let's say you want to get from element 5 all the way to the end of the list. Well, what you can do there is leave out the last number after the colon. So that means go from element 5 all the way to the end of the list. Now, when I say element 5, I mean element with index 5. So let's see, what's index 5 here? Let's see, 0, 1, 2, 3, 4. There's index 5. So we should get from 6 to 10 from this one here. And we do. Okay. So it's a little bit tricky. Here's a very interesting one. If you put a negative number in here, you can do that too. A negative number inside of a slice means reference from the end of the list, not the start of the list. So -5 colon means 5 from the end of the list. But I'll change it to be maybe a 3 instead of a 5. Okay, so that means, basically that means the last 3 in the list. So that gives us 8, 9, and 10. So you can have negative numbers in the slicing syntax as well. Takes a little bit to get onto, but there's several pages about it here. Here's the general rule right here, as you can see. But we do have a number of pages about this, how to create slices. Yeah, here's one from 2 to the end of the list, index 2 to the end of the list. You can also specify 3 values inside the square brackets. Let's see if we can demonstrate that. If we tried nums, and it'll go with 1 colon and 11 with a 2. See, so you can have 2 colons specifying 3 numbers here. So this is a step value here, just like the way it works with the range function. That means you want every other one. So that in fact gives us 2, 4, 6, 8, 10. Remember, index 1 is the 2. And this means a step of 2 here. So you get 2, 4, 6, 8, and the last one is 10. So there's all kinds of combinations of things you can do with a list. You can extract a slice or several elements out of a list with this slicing syntax. It's very powerful. In most programming languages, you'd have to do this with, you'd have to write a function to do this. But Guido made this particularly powerful tool for us called slicing syntax. And you need to know that for your assignment. Now, here's the next thing that comes up in the textbook, the in operator. This is extremely useful. Very awesome tool. The in operator. By the way, there's also a not in operator. Let's just see how the in operator works here. We can go back to that window that we had open here. Let's just review what's in nums. It's from 1 to 10. So I'm going to type here 7 in nums. Notice it shows up in orange, letting you know that it's part of the language. It's an operator. I got it true. 7 is in the nums list. So if you want to quickly check to see if a particular value is in the list, just use the in operator with the name of the list. If I wanted to see if 33 was in nums, well, of course it isn't. So we get a false on that. If I tried 5 not in nums, there's a not in operator here as well. That's going to give me a false because 5 is in nums. Not in nums would be false. It is there. So those are very useful ways of, you're not exactly searching the list, but you're detecting if a particular value is in the list or not. You've got in and not in, whichever one you'd want to use. It's very powerful. Now, here's a really important part of this chapter. A list is a special animal in Python. It's an object type. Now, what does that mean? Well, do you remember when we were working with files, we had to create a file object, a file handle, so that we could use the write and the read line method, right? We use the write method of the file object to write something to the file. And then we use the read line method of the file object to read a line out of the file. Well, objects have these functions that belong to them, but we call them methods when we're talking about objects. So a method, don't let this word method throw you off. A method is just a function that belongs to an object. And a list is an object in Python. So these are some of the methods that are in a list. We've got an append method, which we can use to add on to the end of a list. We've got an index method, which will tell us where this particular value is in the list. Like if we're looking for the item value, this will tell us where it is in the list, or it'll cause an error if it's not there. If we want to insert something in the list, we don't have to put it just on the end of the list. We can put it anywhere we want in the list by specifying the index of where we want to put it in the list. Extremely powerful is sort. We can sort our list. We can sort numbers in order. We can also sort, if we had strings, we could sort them alphabetically by using the sort method. If we want to remove an item from the list, we can do that with remove. And we can also reverse the order of the items in a list, the element. I would prefer to see the word elements there, but you could call them items. So reverse is going to just change, totally reverse the order. So let's see how these work. So once again, I'm just going to fire up an interactive window. Instead of writing a program, we can learn all about lists in this interactive window here. So let's see. we'll try append first. So I'll go with nums dot append, and let's say I want to add 100 onto my list. Done. That's all you have to do. Just specify the value that you want to add onto the end of the list. Let's see what's in the list now. We should see that 100 is the last element. There it is. We just added onto the list. If I wanted to insert a value at a particular index, I could do that too. That's where the insert method comes in. Let's say I want to insert a new value at the start of a list. Well, that would be index 0, wouldn't it? So let's say I want to put, why don't I put -10 at the start of this list? That should do it. You put the index where you want it to be first, and then the value that you want to add to the list. So that should do it. Let's just verify that by displaying the nums list again. Yeah, you can see it starts at -10 now and still finishes with 100. So you can insert at any index you wish. Okay, I'll try. I'll put 55 at index 4. In order to do that, that should do it. Let's see what's in nums. Yeah, here it is at index 4. So that's the append and insert method. Now let's take a look at this index method. Remember what it does, it'll tell you the index of the value that we're looking for here. So if we tried that, let's see, nums dot index, and I'll check that 55 that we just added. We know it's there, so this shouldn't cause an error. It's telling us that it's at index 4. Well, let's check that. 0, 1, 2, 3. Yep, here it is. It is at index 4. Remember, your indexing starts at 0. Okay, so that's a little bit about these methods, so-called methods of the list object. I'm just going to copy that top line there, I think, and generate a new interactive window. Start over again with it. No, it didn't copy. So I'll try it again with list in range. And maybe what we'll do is we'll start at 5 and go to 50. So I'll have to make that 51, but we'll go up by 5s. So that's going to put from 5 to 50 by 5s in my nums list. Now, maybe I'd like to know if 35 is in the list. So I could do that with the in operator, right? So I could go 35 in nums, and that will return true, letting me know that 35 is there. But usually where you might want to use that is to find the index of where it is. So you could do something like this. If 35 in nums, let's report its index. Dex equals nums dot index of the 35. So that should show us what index it's at, and then we could print that out. We'll print that dex value. Well, actually, we could make this a little bit nicer. We'll put it in an F string. We could say found 35 at index, and then we'll put our dex inside a placeholder for a nice F string. So let's see what we get from that. Now, what we're testing here, we're testing this index method now. And the index method will tell us the index of the 35. But we're testing it first. Now we know it's there, so it's not going to cause a problem. So let's see what we get. Yeah, it's at index 6. Well, let's just check that. 0, 1, 2, 3, 4, 5. Yep, it is at index 6. There it is. So that's useful. You can use the in operator to determine if a particular value that you're looking for is in the list. And then if you want to know where it is in the list, use the index method of the list object. And the list object is the name of your list. Now, we could sort this. Let's just see what's in our nums list again here. Well, I guess we didn't change it at all. So we know what it is. It's already sorted. Why don't we reverse it? Why don't we try that reverse? So let's go with nums dot reverse. Let's see what that gives us. Yeah, now they go from 50 down to 5. So that reverse method is pretty smooth. It just reverses the order of the items. And if I didn't like that, like let's say let's insert a couple of numbers in here. I'll go with nums dot insert at maybe at index 5. I'll insert 22, and maybe at index 8, I'll put in 33. Okay, so let's see what's in nums now. Yeah, there's my 22, and there's my 33. But let's say now I want to sort them in ascending order from low to high. Well, it's as easy as nums dot sort. Done. And then we can display that. And as you can see, the 22 is in the right place. So is the 33 in between 30 and 35, just like it should be. So you've got some really powerful tools available for working with lists. And they're called methods of the list object. There's the only one we haven't used here is remove. So why don't we try using that one? Why don't we, for example, why don't we get rid of that 22? Kind of messes up our list here. So why don't we try to locate where it is? First of all, let's get the index of that 22. So what we could do is we could say dex equals nums dot index 22. That'll store the index in the variable dex. Now we should be able to get rid of that value 22, but I'm not actually going to use the index. I'm just going to get rid of it by putting 22 in there, the value of the item. So I'll just go with nums dot remove the 22. And let's see if that did it. Yeah, it's gone. Let's get rid of the 33 too. We could do that. So we're back to where we were. Very, very powerful feature of Python lists. Now we're not doing anything important with these right now. We're just sort of fiddling around with lists, learning what we can do with them. But what you can do with them is absolutely amazing. Whenever you want to keep track of a number of values, whether they be numbers or names, or even names and numbers, you can do it very nicely with a list. It's a tool that you can use to great effect in your applications that you might be creating. Now, the next few pages in our textbook are all about how to use those methods. Pretty much what we just did there. Like here's a little bit about the index method. And then here's the insert method. And there's the sort method. There's remove. And so the last one's going to be about the reverse method. Here it is here. So there's several pages on how to use those methods. Now, as well as the remove, there's a DEL that you can use to get rid of a value by its index. Okay, so this allows you to remove an element by its index. So let's see what we could do here. Let's say I want to get rid of the 40 but I don't want to use the remove function, which obviously would be the easiest way to do it. But let's just see if we can use that del function. Now, the way that works is it's not a method of the list. It's just a function that works with lists. It's a statement, I guess you could say. It's a statement that works with lists. But you have to specify the index of what you want to remove. So let's just see where that 40 is. Index is, well, why don't we get its value here? We could say dex equals nums dot index of the 40, just to see what the index is for that 40. And we'll use it to get rid of it. So we'll go del nums and then if you look at the syntax back here, all you need to do is use square brackets, not round parentheses, because this is not a method. Okay, this is a statement. So you use the square brackets, and now I'm going to put the index that I want to get rid of. So that should get rid that should get rid of the 40. So let's see if that is in fact happened. Yes, the 40 is gone. Okay, so you've got two ways you could remove an element out of the list. You could use the remove method and the name of the list object and the remove method, or you could use the del statement and put the index of the element that you want to remove inside the square brackets. Here's two very interesting functions that work with lists, min and max. If you want to get the lowest and highest value in a list, you can do that very nicely with min and max. Let's give you an example. What I'll do here is what I'm going to create a slightly different list. I'm going to create a list in a slightly different way here. We'll do it with a loop and the random module, because this is something that you might have to do from time to time. So we'll say we're going to import the random module, and we're going to use the alias RA to represent the random module. Now, let's create an empty list. Okay, so I'm sorry to keep using the nums as the name of my list, but it's a pretty good name for a list that has numbers in it. And now what I want to do is let's say I want to put 50 random numbers in that list, all between 1 and 100 inclusive. Well, that means I'm going to run a loop 50 times and add random numbers in each cycle of the loop to this list called nums using the random module. So I think what I would do is something like this for n in range 50. We know that that's going to run 50 times, right? Definitely, this is going to run 50 times. Now, what do I want to do 50 times? I want to generate a random number. So I'll just call it n. Oh, no, I better not use the same variable as my loop control variable. I'll call it RND, short for random. And I'll use my random module and the randint function, randint. And I want it to be, I think I said from 1 to 100 inclusive. So that means 1, 100. By the way, that's the way random works. If you put 1, 100, you will possibly get from 1 to 100. You don't have to say 101 like you do with the range function, not with randint. Now there is another function in the random module called randrange that would work that way, where you would have to put 101 in here. But why bother? Just use randint. It's a little easier to remember. Okay, so there's a random number. Now, what do I want to do with that? I want to add it to the list. Well, that's the append method, right? So what we want now is nums.append that random number that we've just calculated. So that should do it right there. And at the end of all that, let's see what's in our nums. Yeah, we've got 50 random numbers, all between 1 and 100. They're not in any order at all. We've probably got some duplicates in there, but we've got 50 random numbers, all from 1 to 100 in a hurry. Now, I wanted to, the reason I brought this up is I wanted to show how we could use this with the min and max function. So let's see what max of nums is. Let's see what the largest number is. I wonder if we got it 100. No, the biggest one we got was at 98. Let's see what the minimum was. We could have a 1. I'm not sure if we got a 1 or not. Let's see. With the min function. No, the lowest we had was a 2. So the max function will show you the highest value in your list. The min will give you the lowest value. And remember, you've got the len function too, which tells you how many elements are in the list. So don't want to forget about that one. Whoop. The len function tells you how many items are in the list. Well, we know there's 50. Hey, here's a really powerful one. Do you want to add up the numbers in a list? There's a sum function. There it is. There's the sum of those 50 numbers. Look at the power that we have at our fingertips when we work with lists. Absolutely mind-blowing. The potential for writing programs now is very great indeed. We can do wonderful things with our programs now. Okay with that? I know I'm going kind of quickly here, but I'm actually just covering everything that's in the chapter. You should read it, and you should try some of these things like I'm doing as you read the chapter. That's the best way to consolidate your knowledge. Try some code while you're reading the textbook. Let's see what's next. Copying lists. Yeah, if you want to make a copy, if you just say list 1 equals list 2 like this, you might think that that's making a copy of list 1 called list 2, but in fact it's not. That actually doesn't copy the list. What it does is it gives you 2 variables that point at the same list in memory, as this graphic here illustrates very nicely. List 1 and list 2 refer to the same list. You didn't make a copy at all. If you actually want to make a copy, you need to use a different procedure. What you could do is you could let list 2 be an empty list, as is shown here in the next page, and then go through the first list and append to the second list each item that's in the first list. That would work nicely. Here's another way you could do it. You could just let list 2 equal square brackets plus list 1, and that'll do it too. Okay, now processing list comes up next here. Let's see what this is all about. This is going to be about working with loops, obviously. Yeah, look at that. There's a for loop right there. Here's another one down here. Going to go through a list. And here's the output of that. Totaling the values in a list. Well, we could use an accumulator and add them all up, but I just showed you that we also have a sum function. So why bother? Just use the sum function. You certainly could create an accumulator, as is shown here in lines 8 and 9. Let it have a value of 0. And then as you go through the list, you could add each list element onto the total. That's the normal way you use accumulation. But since you've got that sum function built in, by far, that's the easiest way to do it. And if you want to get the average of a list, well, that's also pretty straightforward. Let's just show you how we could get the average of this list here. If I wanted to get the average of this list, I would just take the sum of the list and divide it by the length of the list, right? Done. That's the average, 50.86. So finding the average of a list is pretty straightforward. Now, what they're doing here is they're doing it with some code by creating an accumulator and adding them all up, and then they are dividing by the length at the end. But I think you'll agree that it was actually easier to use the sum function and the len function. Now, I wanted to get to this because this is pretty important. Custom function. Oh no. You might have thought, oh, that you were through with functions. I'm sorry, you're not. We still have to learn how to use functions in the remaining chapters. In fact, you're always going to be writing custom functions if you're a Python programmer. That's basically what you're going to be doing on a daily basis. You're going to be writing functions. So let's see what we have here. passing a list as an argument to a function. Okay, well let's try that with the program. So let's write our first program. So far we've just been messing around here, but what we'll do is we'll create a script window here, and let's write a program. I'll send this to you when we're done here. So I'm going to call this list funcs.py. And I wanted to put a C in there. And we're going to go with, I'll tell you what we'll do. I'll use triple quotes to describe the problem that we're going to do here. What we'll do is we'll, what will we do? I've got an idea that will be quite helpful for you for your assignment, actually. So let's generate a list of random integers. Let's specify how many we want. So let's make it 100. We want to get 100 random integers, all from about from 1 to 100. Okay, so we could have a 100, we could have a 1 in there too. Okay, then pass this list to a custom function that we're going to write here in a minute as an argument. And as you know, when you put the name of a variable inside the parentheses when you run a function, that's called using it as an argument. Okay. In the custom function, what we'll do is let's do something kind of weird with those list methods and so on here. Why don't we say we're going to remove, or I think I'll use the word extract instead. Let's extract all, why don't we get all the multiples of 5 to a sublist, a smaller list, obviously, right? We'll just get all the multiples of 5 to a sublist. And then what we'll do is we'll return that sublist. I'm sorry, I'm a little trouble here. We'll return the sublist back to main. Where we will sort it. We could have sorted it before we return it, but let's return it first and display it. So in other words, we're going to print it. Okay, so that's what we want to do. Now, I haven't been using my dunders yet, so I guess this is the first program that we've written, and we want you to do this all the time now. We want you to use this because this is what you're going to see in any Python book in the future or online. You're going to see this being used. And we'll go with our def main here. And we know that we're also going to have a custom function. I'll just put it down a little bit down here. I'll call this, let's see, we're going to subtract, we're going to extract multiples of 5. So I'll call it make 5s. We'll call it make 5s. But the first thing we want to do I think we should work through the instructions in order. So let's generate a list of 100 random integers, all from 1 to 100, but they have to be random numbers. So obviously that means we need to import random. Now you don't want to import inside main, okay? Do all your imports outside of main. So we're going to import random as RA. And by the way, I'm not defining main. I'm not defining this function inside main because it's not indented. Okay, this would be a mistake. I see some people doing this. You don't want to do that. Don't define your functions inside main. If you do that, they're only accessible to main. We want to put them out here so they're accessible to the whole file. So what do we want to do in the main function here? We want to generate a list of 100 random integers, all from 1 to 100. Well, that makes me think of a loop. We got to run a loop 100 times. Easiest way to do that is with the for loop in the range function. So I think what we could do is say for n in range 100. We know that's going to run 100 times. And what do we want to do? We want to generate a random number from a random integer from 1 to 100 and add it onto this list. Oh, wait, I don't even have a list. So first of all, I got to make an empty list. Very first thing we got to do here is make an empty list. And so you want to do that at the very start of your program. So I'll call it my list as an empty list. That's all you have to do to make an empty list. I'll put a comment on that line. That's how you make an empty list. And that's what we want to start with, because it's going to start empty and then we're going to add our random numbers to it. Okay, so now what we want to do inside this loop that's running 100 times, well, we're going to use my list dot append. And what do we want to append? A random number from 1 to 100. So this is where we would use RA dot randint 1, 100 inside the append. Now I'm doing it with just one line here. Earlier, over here, we used 2 lines to add some random numbers to a list. We basically did the same thing over here. Okay, but there's just 50 here in this case. And we did it with 2 lines. We generated the random number first, and then we appended it to the list. But it's very common in programming to embed one, in this case, one function, the randint function of the random module, inside the parentheses of another function, the append method of the list object. So this is not unusual. So don't let that throw you off. Okay, so that should make our list. Now, what do I want to do with that list? Once I've got that list made, I want to pass it to my custom function. So that means I want to run my custom function, which is called make5s. Make5s, and I want to pass my list to it as an argument. So I would do it just like that. So I'm going to put a comment on that one. I'm going to say call the custom function here. Call means run in programming lingo. When you call a function, that means you're running the function. Now, but we're going to return the sublist to main. So since this is supposed to be a value returning function, I've got to catch the list that's going to be returned by this program or by this function. Now we haven't defined the function yet, but what we want this function to do is extract from the big list only multiples of 5. So in order to do that, and also return it back to, whenever you watch for that word return, if you want to return the sublist to main, well, then that means you got to catch it in main. So I'm going to call it here, I'll just call it 5s. I'm going to call the list that is returned 5s. That'll be the name of the list, that's the sublist. So now let's make the list in our custom function here. Now, because because we've defined, because we're calling this with an argument, we need to have something in here too. So I'll just call it LST here. We could call it anything we want. I guess I could call, why don't I call it nums? We've been using nums all along today. So I'll call it nums here. I could even call it my list, but that might make you think that they're the same variable, and they are not. This variable here is only going to be known inside this function. This variable is known inside this function, inside the main function. This is a very important concept that you have to keep straight. So what we're going to do, the list that we're going to operate on inside this function will be known as nums. Now, what do we want to do? We want to extract the multiples of 5 and make a sublist. So I guess what that means, we need to go through this list one by one, detect multiples of 5, and when we do, add them to a new list. Okay, so I guess we need to make a new list. So we need to do that for starters here. So I'll call this list 5 in this case. Okay, list 5 equals a new empty list. Okay, so initially that list is empty. Now what we're going to do is we're going to go through the nums list, detect multiples of 5, and add them onto the list. So for n in nums, what we want to do is detect the multiple of 5. Well, that means we're going to need an if expression, right? If n, now I need your help here. I need your input. How can I detect if n is a multiple of 5? You know the secret here? We'll probably put.
Is it zero? It has to equal to 0, right? If it's divisible by 5 or something like that. Oh, I'm trying to remember.
Yeah, you got the right idea, I think.
Okay.
What has to equal 0 though? If you divide it by 5 and the remainder is 0, then you know you have a multiple of 5, right?
Right.
So we have to use that remainder operator, the percent operator.
Equals.
Right, very good. So it would be if num percent 5 equals 0. Now we've detected a multiple of 5. And what do we want to do with that n variable? Well, we want to add it onto our list 5 list. So list 5 dot append that n variable. That should do it. We could go all the way through the nums list one by one, letting each number be n. If it's a multiple of 5, we'll add it onto the list 5 list, which initially was empty, but it won't be empty once this finishes. But once we've created the list now, we have to return it back to main. So what we have to say here is return list 5. We want to return that list. That's it, I think. I think that's all we need there. And I do have my Dunder's expression down here, so that's a good thing. So so now let's go back. We're through with this function. That's it. So now let's see what else we have to do. We return the sublist to main, where we will sort it and display it. Now it doesn't say how to sort it, so I assume that means we're going to sort it ascending. If it was going to be descending, that would be likely specified exactly. So I think what we want to do now is we just want to sort that 5s list. So that would simply be 5s dot sort. That should sort it in ascending order. And now display it. Now I should have been a little bit more detailed here about how to display it. All on one line separated by spaces. Okay, so we'll print the sublist all in one line. So now what we want is a loop. We're going to go through the 5s list one by one. So the best way to do that is definitely with the for loop. So now we could say for x, so I don't have to use n all the time. I'll let x be each variable in the 5s list. So we could say for x in 5s, print, and I'm going to go with an F string, which we would like you to use F strings. So we'll put inside the square brackets here, we'll put our X variable that we're going to print out, but we want to also finish the line with a space. So we'll go like this. That should print them all in one line, I think. So let's give that a try. And I haven't saved this yet. I'm going to call it listfuncs. I'll save it on my desktop when I run this right now. Here we go. Hopefully we haven't got any errors, but if we do, we'll fix them up. I don't get my programs right first time every time, I admit it. So I'll save it on my desktop, and I'm going to call it list_funcs with a C in there. I guess that's it. And they are in order. As you can see, they are sorted, and they're all multiples of 5. Now, this isn't a great program because I think we should have shown what the original 100 numbers were, right? That would have been a much nicer feature. So, so what we could do is, I guess we'd have to make another list in order to do that. Or what we could do, maybe this wasn't the best idea if I would want to print them all out. So I'm going to extract that from there. I'm going to cut that out of there. And I will do it in 2 steps like we did up here. So I'm going to say RND, you could call it anything we want, of course, right? It's our program, equals RA. Oh, I could paste it in here, what I cut out, RA.rand in 1 to 100. And then right here, I could put my RND. Now, the reason I wanted to do this is I want to display the original list of 100. So now I can do that with a print statement, print and an F string. And we'll put our, I'm sorry, I need a loop here. And the easiest way to do that would be, well, actually, we're already in a loop, aren't we? So all we need to do is print the value of our RND variable. So all we need is to print rand here and finish it with a space, I guess, just so they're not all jammed together. So I think that will generate the random numbers, but it'll also print them out, which we didn't have over here when we ran this the first time. So I think this will be a little bit superior output. So let's try it again then. So I think we can get this all in one screen. Here we go. We could if I didn't make an error message. I didn't close my placeholder, as you can see here. I needed my closing curly brace right there. Okay, we'll try it again. Okay, so there's the first 100. That's interesting. The very first number I got was actually a 100. Amazing. But so here's all 100, and here they are, multiples of 5 in order, as you can see. Got a lot of 70s, which is interesting. Okay, so now I'm not doing much else with this list. I suppose what I could do is I could get the minimum and the maximum and that sort of thing. Like we could try some of those other functions, right? Maybe what I could do is, let's see. Maybe what I could do is once I've got this list here back in main that I can work with, right? That's the critical step right there that most people have trouble with. Perhaps that was a problem for you when we did chapter 5. If a function returns a value, you got to catch it in a variable. Now we can work with that variable in the rest of main. We can sort it and go through it one by one. But what I was thinking that we could maybe do here is we could perhaps get the largest one. But what we could do that maybe But why don't we try using the in operator? Why don't we see if 55 is in or not in. Let's say we want to make sure 55 is in the list. So what we can do is say, if 55 not in fives, what we'll do is we'll add it. So to do that, we would just say fives dot append 55. So that should add the 55 if it's not there. Now we could put a little statement in here, I suppose. We could say, and this doesn't even have to be an F string. We could just say 55 was absent. So it was added. Now, I don't know what's special about 55, but it's just a number that came to mind that we could make sure that 55 is in the list. And of course, it is a multiple of 5. It's quite possible that it is going to be in the list. So what we could do, we could put an else block here after our if, and we could say 55 was already in the list. So nothing was added. Too many D's there. Okay. Excuse me 1 second. I'm going to let my dog out. It's always better to let the dog out, I've learned. Okay, we're back. So I want to try that program again. So I'll just kill this window off because it's getting a little bit full. So I'm obviously I've changed the requirements up here, but we can modify those perhaps later. So here we go with the run. Let's see if this thing works. Okay, so we got something. Let's see what happens here. Oh, look, this came out on the same line. I'm not fussy about that. And the reason that happened was, you see, when we printed this line here, we didn't actually finish the line, right? Because we were using the end operator, which cancels the new line. So really what I should do here, I should put a \n here and a \n here to make sure that this comes out on its own line, right? It didn't really want to add that on the same line as these numbers. So I'm going to run it again, and I think the output will be a little bit better. Yeah, there, as you can see, 55 was already in the list, so nothing was added. Yeah, here it is right here. Okay. And as you can see, we've got them all sorted from low to high. We'll try it again. Once again, it was already in the list. Well, looks like it's 55 is a lucky number. Keep trying it until we don't get one. Huh. Amazing. Ah, here it is, finally. 55 was absent, so it was added. And that's where it should be. After sorting, of course, it should be right between the 50 and the 60. So hope you're okay with that. This is the sort of thing that we want you to be able to do. We definitely want you to be able to create a custom function in which you work with a list. And in this case, what we were doing is making a sublist called list5, which is just going to be made up of multiples of 5. But we could ask you to do something else, like some other task to make a sublist. Okay. Any question about this one? We pretty much covered most of this chapter, except for one very, very important part. and that's list comprehensions. And by the way, we not only passed a list to a function, we did that right here in this line. We passed the list, my list, to the function as an argument, and we also return the list. We return the sublist, and we caught it. So those are the two parts of working with a list and a custom function. You pass it to the function, and then you also need to know how to catch a list that's returned by a custom function. So we've demonstrated both of those today. And there's just one more concept in this chapter, which I think the best way to demonstrate that is by looking at a few examples. So I hope you're okay with this program. What I'm going to do is I'm going to send this to you in the chat right now. Send that program to you in the chat. Okay, you should have it on your system now. The very same program that we just wrote. And now what I want to do is I want to take a look at, if we go ahead a couple of pages here, there's returning a list, which we did do. And then I wanted to get to a couple other items here. Some more, these are just some sample programs I work with lists. I encourage you to take a look at them. They're pretty good. Oh, this is an interesting one. Randomly selecting list elements. As it happens, the random module isn't just for generating random numbers. You can also randomly select one or more items out of a list. There's a choice function, function in the random module that'll randomly select an element in the list. You pass the list as an argument to the function, it'll randomly return one of the elements out of the list. And there's also one called choices that will return multiple random numbers from a list. And to do that, you use k equals n. You actually have to, here's an example down here. Random choices, numbers is the name of the list, and then k equals 3 means we want to choose 3 random numbers out of the list. And as you can see, we got 8777 here. And there's one more. If you want to get unique elements, no duplicates, you use the sample function. So if you want to say random.sample numbers, k equals 3, then you will get 3 elements out of the list, but without duplicates. Like up here, we had 2 7s. So if you don't want duplicates, you use sample. So we could demonstrate that fairly quickly in an interactive window, I think. Let's make a little list here. Hey, maybe we're thinking about I don't know why I'm thinking of this one, but when I was in high school and we had a dance, we would, there'd always be door prizes for people that came to the dance. And I mean, it was just based on what your name was, like it was a draw or something. So I'm just going to make a list of names, and I'll go with these names here. Okay. Oh, I got too many closing brackets here. Let's see, Penny, Jenny, Lenny, Minnie, Kenny. Okay, so it looks like I've got a list here. Let's just verify that that got created properly. Okay, now let's say I randomly want to pick somebody as a prize winner. So all I have to do is say pals dot. Oh no, I'm sorry. I have to import the random module. Import random as RA. So now we would just say RA dot choice, and then the name of my list, which is pals. And Benny, you won. Benny got a free bottle of Coke. Okay, so it randomly chooses one, as you can see. But let's try choices, and we'll specify that we want more than one. So we're going to choose two names. Then it would be pals, comma, K equals 2 if I want to get 2 out of the list. Okay, I could have got 2 the same. It's possible that that could happen. If I wanted to get 4 out of the list, I'll probably get duplicates with 4. Let's see. Yeah, I got Kenny twice there. But let's say I don't want duplicates. Well, then that's where you use sample. Not choices or choice. Sample. But leave it at 4 if I want 4 unique names out of the list. And there they are. So that's pretty cool. Now, most programming languages, you'd have to write some code to do that. But Python's got this beautiful random module that allows you to very quickly randomly select some elements out of a list. I love Python. It's so cool. Very easy syntax. It's fun to work with. Well, we're almost done. Not quite. One more thing to take a look at. And lists and files. We could certainly do that. We could make our list as an empty list. We could read some data out of a file and append the data to our list, right? That would be pretty straightforward, I think. So I'm going to skip that. What I want to get to is, we're almost out of time here. I want to get to list comprehensions, which is the most fascinating part of all about working with lists in Python. List comprehensions. Unbelievable power at your fingertips for making a list. You can actually put code inside the square brackets to create a list. Here's a simple example right here. Look at that. Item for item in list 1. We've actually, wow, it's pretty crazy. I think we can maybe show you some possibly more interesting examples, I hope. Let's see, we could, let's see, I could say, okay, let's say I want to generate some random numbers. We'll call it nums. So I start with the square brackets, but now I put code inside the square brackets. So I'm going to go with X for X. It's supposed to be 4. X for X in range. And I'll go with 1, 11. And as you know, that should go from 1 to 10, right? That should go from 1 to 10. So let's see what that does. Look at that. Now, obviously, I could have done that with list and range, right? But isn't that cool? You can put code inside the square brackets to make the list. Let's make something a little bit more interesting. I could, for example, make a list of Fahrenheit temperatures. I could say Fa equals, and maybe what I want is, I'll go with T for temperature. T for T in range. I'm going to start at -40 and go up to +40. Now that means with the range function, I got to use 41, right? But I'll go up by 5s, from -40 to 40 by 5s. Okay, let's see what that gives us for fall. Amazing. Unbelievable. We could even use the random module in here if we wanted to. Like if I wanted to make some random numbers inside here, this obviously here I'm not making random numbers at all, but we could say rands equals Since I have imported random, it should be still available to me here. So inside my square brackets, I'll just go RA dot rand int, and I'll make it 1, 100. And let's say I want 20 of them. So I could say for n and range 20. Look at that. 20 random numbers, all from 1 to 100. Unbelievable. You can very, very quickly create a huge list of values. They could be random, or you could specify that they're not random. Using the range function is a good way to do that. But you put the code right inside the square brackets. Very, very powerful. Now, the reason that I wanted to make that FA one, let's just redisplay the FA. I think we still have it. Yeah, there's the FA. I could now create a list of Celsius temperatures that are equivalent to these with the list comprehension. I could, for example, say cell equals. Now you have to know the formula for converting between Fahrenheit to Celsius. And what is it? I think it's Fahrenheit to Celsius. Is it F minus 32 times 5/9? I think it is. So, so what we want here is let's see, how will we write this? We'll go F. I made it kind of hard by going this way, but let's see if we can get this done. F minus 32 times 5/9 for F in Fa. So for every F in Fa, let's apply this formula to every F in Fa. Let's see what we get here. There's the equivalent Celsius temperatures to these Fahrenheit temperatures. Now, obviously, they're not rounded off at all, but minus 40 Celsius is also minus 40 Fahrenheit. 40 degrees Fahrenheit is 4.444 in Celsius. So obviously, we would need to round these off a little bit, which we could do when we print them out. But look at that. You can make one comprehension like we did for Fa up here for the Fahrenheit temperatures. Then you could, if there's something related to Fahrenheit like Celsius is, you could use that Fa comprehension, that Fa list, to make another list with a comprehension, which is what we did here. Now, we don't expect you to do anything like that, but we do expect you to make simple list comprehensions. Let's see, we'll try one more here. Let's say I want to make some odd, a list of odd numbers from 1 to 100. So I think the way we do that, we would go with X for X. And let's say I want 20 odd numbers. X for X in range. I'll go with 50 here, but I only want them if they're odd. If X% 2 equals 1, right? That's the test for an odd number, right? So let's see what we get there. Amazing. So you can put an if expression inside your comprehension. Pretty powerful. Well, we've just gone through the whole chapter, and I'm sure you're probably, if I could, if you had your cameras on, I'm sure I'd see, you'd be looking like a deer in my headlights of my car. But that's it for today, folks. Y'all have fun, okay? And have a great Thanksgiving. Be safe out
Thank
there.
you.
Be safe out there, and we will see you next time. Remember, no classes Wednesday, Thursday, Friday next week. Have a good one.
Thank you, you too.
Okay, bye-bye now.
Bye-bye.
Bye.